So first, does anyone have any homework questions you'd like me to talk about? Yeah. Okay. Well, if it comes up later, let me know. Yeah. Yeah, so on the weekly assignments, I'm not going to go into too much detail, but I can maybe say a couple things about it. Weekly assignment 1. Go. Number 2, you said? Okay. Okay. Yeah, so you can use any conversions you want, so you can use meters directly to feet. I guess I give you some. Oh, I give you the ones to use down here. So meters to feet, minutes to seconds. So you have all that stuff. So just when you write this, remember to start it out as 140 meters divided by seconds times seconds, and then just go through the conversions from there. Any other clarifications or anything that anybody wants on the weekly assignment? Okay, well, let's get into some new stuff. So first I'm going to give you a problem to work on and just give you some time to work on it, and then I'll go through it. And then we'll get into vectors a little later on today after that. So this is an example problem. And let's say that an object is thrown into the air. And we don't know the height that it's thrown from. But we do know that the highest point it reaches is 10 meters. And it's thrown from, it's thrown with a starting speed of 5 meters per second. What height is it thrown from? Okay, so the first part of any question like this is to choose a zero position and a positive direction, and then a time zero and a time final. Just so that we all see the same numbers the whole time, I'm going to choose the zero position and the positive direction. So I'm going to choose the zero position to be on the ground and the positive direction to be up. Okay, but so the first thing that I want you to do is think about what's going to be your time equals 0 and what's going to be your time final instant. Okay, so this, you don't have to take too long. Okay, so what are we going to choose as our time equals 0 instant? Yep, the instant that it's thrown. And what are we going to choose as time final? Yep, the instant that it reaches the highest point. And whenever one of your two instants is at the highest point in the flight, there's one bit of information that always goes into the problem once you make that choice. Do you remember what that is? So there's one bit of information that always goes along with the highest point. Velocity is 0 is what I'm thinking of. So you always know you're going to use the velocity is equal to 0 at that instant. Okay? So be ready for it. Because when you finally get to say it, it's going to feel really good. Okay, so now we want to figure out what variables we know and want. So just go through the list. Remember, the list of all the possible variables is time final, acceleration, PI, PF, VI, and VF. So see if you can, I'll give you a little more time for this. See if you can fill out this table of what we're trying to find and what we know. Do we know acceleration? We do, in any free fall problem, remember acceleration is down at 9.81. So A is equal to, plus or minus 9.81 meters per second squared. In this case, is that going to be positive or negative? Negative, because I chose positive up. Okay, so this is going to be negative because it's down. Do we know the initial position? We don't know that. We're trying to find that. We're trying to find the position at time equals 0. Okay? Do we know the position at time final? That we know. So P final is 10 meters. Do we know the initial velocity? Okay, so let's think about that. So velocity is the speed, and then with a plus or minus to indicate the direction. The speed is 10 meters per second. Is this moving in the positive or negative direction at time equals 0? Positive, very good. Just right. So, and then, this is the one we've been waiting for. Do we know V final? 0, right. Okay, so here's a complete list of what we know and what we're trying to find. Now take a couple minutes and see if you can find an equation that'll let you solve for PI and go through it and come up with an answer. Okay, well, the equation that is going to work here is this one, 2A times the quantity PF minus PI is equal to VF squared minus VI squared. So let's check and make sure that this will work. So it has to have PI in it if you're going to solve for PI, and it does. And now let's go through all the other variables in the equation and make sure we know them. A, yes. PF, yes. VF, yes. VI, yes. So we know this will work. So we have 2 times negative 9.81 times the quantity 10 minus PI is equal to 0 squared minus, I used the wrong number for this, didn't I? The initial velocity isn't 10 meters. The initial speed isn't 10 meters per second, it's 5. Okay, so 5 squared. So this is negative 19.62 times the quantity 10 minus PI is equal to negative 25. now you can divide both sides by negative 19.62, and you get something like a little over 5/4, like 1.26 or something. So 10 minus pi is equal to can someone divide that for me? 25 divided by 19.62? 7? 1.27. And now you can, so 10 minus 1.27 is equal to pi. So pi is equal to 8.73. Thank you. Okay? Any questions about that? Let's do one more part of this. Let's calculate how long it takes. So that's the elapsed time from when it's thrown to when the ball hits the ground. So the first, we've already done one part, but that doesn't mean that our choices of time equals 0 and time final are still going to work for this. Sometimes they do and sometimes they don't. So you have to start by thinking, are we going to use the same time equals 0 and time final instant, or do we have to change them? So think about that for a second. Is there any reason for us to change the meaning of our time equals 0 or our time final? Yeah, that's exactly right. Time final is going to have to change because now we're trying to find out something about the instant when it hits the ground. And that wasn't one of our choices before, you know? So that's going to have to be either time equals 0 or time final. And since that's the last thing that happens before the acceleration changes, it sort of clearly has to be time final. So our time equals 0 instant is still going to be the same as it was. That's when it's thrown. But time final is going to be the instant, you can think of it as the instant just before it hits the ground. Okay, well, now that we've chosen those, see if you can figure out what variables we know and what we're trying to find.